Passenger planes designed for efficiency and comfort. Passenger planes, also known as commercial airliners, are primarily designed to transport passengers comfortably and efficiently over long distances. They typically operate at cruising speeds ranging from Mach 0.75 to Mach 0.85, which translates to approximately 500 to 600 miles per hour. This speed range is chosen to balance fuel efficiency, passenger comfort, and noise reduction. At higher speeds, air resistance, also known as drag, increases exponentially, leading to a surge in fuel consumption. Additionally, flying too close to the speed of sound, which is Mach 1, can cause sonic booms, which are loud, disruptive shockwaves that can disturb people on the ground. Military fighter jets engineered for speed and maneuverability. Military fighter jets, on the other hand, are designed for speed, maneuverability, and combat effectiveness. They typically have powerful engines that can propel them to speeds well above Mach 1, with some fighter jets capable of reaching speeds of Mach 2 or even Mach 3. This exceptional speed is crucial for their combat roles, allowing them to intercept enemy aircraft, engage in aerial dogfights, and evade enemy missiles. Fighter jets are also designed for superior maneuverability, allowing them to perform tight turns, rapid climbs, and sudden descents. This maneuverability is essential for evading enemy fire, engaging in close quarters combat, and performing complex aerial maneuvers. Fuel efficiency versus combat performance. Fuel efficiency is not a primary concern for military fighter jets, as their combat effectiveness takes precedence. While they may conserve fuel during routine training flights, they are capable of burning enormous amounts of fuel to achieve their maximum speed and maneuverability during combat missions. In contrast, fuel efficiency is a paramount concern for passenger airlines, as it directly impacts operating costs and ticket prices. Airlines carefully optimize their flight paths and cruising speeds to minimize fuel consumption while maintaining a comfortable and efficient passenger experience. Sonic boom restrictions. Over land, supersonic flight is generally prohibited due to the disruptive nature of sonic booms. Sonic booms can cause noise pollution, damage property, and even cause physical harm to humans and animals. As a result, passenger planes are typically restricted to subsonic speeds, even if their engines are capable of reaching supersonic speeds. Military fighter jets, however, may be authorized to fly supersonically over certain areas for training or combat purposes. They may also utilize specialized techniques, such as pulling the nose up or flying at higher altitudes, to reduce the intensity of sonic booms. Conclusion. The difference in cruising speeds between passenger planes and military fighter jets stems from their distinct design philosophies. Passenger planes prioritize comfort, safety, and fuel efficiency, while military fighter jets emphasize speed, maneuverability, and combat effectiveness. These design considerations dictate the aircraft's engine power, aerodynamic shape, and operational limitations. As a result, passenger planes typically fly slower than military fighter jets due to their focus on efficiency and comfort, while fighter jets prioritize speed and maneuverability for combat purposes.